Okay, so when you add a solute to water, its boiling point increases and its freezing point decreases. But by how much? What would the new freezing and boiling point be? Well, in order to know that, we need to know one thing. What's the concentration of the solution? See, because if we know the concentration of the solution, we can use that concentration to find the new boiling point and the new freezing point. Now, it would be great if we could use molarity. The problem is that in order to find out what the new freezing and boiling point is, we need to know exactly how much water we're boiling and freezing. And molarity doesn't give you that. Here's why. When you want to make a solution in terms of molarity, you put in the solute and then you fill the rest of the way with water. So the more solute you put in, the less room there is for water. So molarity has a variable amount of solvent in it. We know how much solute there is, we know the total volume of the solution, but we really don't know how much solvent, how much water we're putting into the solution. So molarity isn't really going to help us here. We need a unit of concentration that we will know exactly how much water we have, and that is molality. Molality is how many moles of solute there are per kilogram of solvent. You see, in molarity, we wanted to know how many liters of solution. And remember, the solution contains both the solute and the solvent. When we do freezing point and boiling point problems, we need to know exactly how much water there is. So molality is the way to go. Remember, the density of water is 1.00 kilograms per liter. So for water at room temperature, you can pretty much say that a kilogram of water is going to be a liter of water. So solving the problems is exactly the same as calculating molarity, except you're just going to divide by a different thing. So, what is the molality of a solution that contains 20 grams of sodium hydroxide dissolved into 200 grams of water? Well, the same steps apply as before. First, convert the grams of your solute to moles, because molality is moles of solute per kilogram of solvent. So to do that, we divide by the formula mass of NaOH. Na is 23.0, O is 16.0, and H, of course, is 1.0, which adds up to 40.0 grams per mole. Now, 20 divided by 40 is half a mole, or 0.500 mole, right? 3 sig figs, 3 sig figs, 3 sig figs in your answer. Great. Now we've got moles, let's divide by kilograms of solvent. Divided by, well, we have 200 grams of solvent. Divide that by 1,000 and you get 0.200 kilograms of solvent. And when you divide 0.5 by 0.2, you get 2.50 molal. And that's the concentration of the solution. Now once you know the molality, you can easily find the new freezing and boiling point. Again, it's just like molarity, except instead of dividing by liters of solution, we divide by kilograms of solvent. Otherwise, the math is exactly the same.